Okay, so we're going to work on simplifying this complex fraction. Remember, a complex fraction is a fraction that involves negative exponents or fractions within the bigger fraction. So when you have one of these fractions with the negative exponents, what we want to do is rewrite this with positive exponents. So what that means is if I have r to the negative 2 power, I'm going to write that over here. If I had, just think of it on its own. If I had an r to the negative 2 power, think of it as being over 1. That would go to the bottom and it would give me 1 over r squared. So I'm going to write 1 over r squared. This is still in the, this big fraction bar right here. That's still right there. So I'm keeping that in the numerator. Minus s to the negative 2. Bring that to the bottom of itself, so it's going to be 1 over s squared. Then our denominator, we have r to the negative 1, so that's going to be 1 over r to the first power, minus s to the negative 1 is 1 over s to the first power. So when you have those negative exponents, we're going to rewrite it like this, and now we're going to get to do that little denominator trick to get rid of those fractions and simplify this complex fraction. So what we do is we focus on the denominators of the fractions within this large fraction. So if you look at your denominators, you have an r squared, an s squared, an r, and an s. So you basically want to come up with something that includes all of that. So for example, if I do an r squared, I would say, okay, well, this denominator is r squared. I've got my r squared over there. Well, this denominator is s squared, so I need an s squared. This denominator is r. Well, I've already got a couple r's, so I'm set there. This denominator is s, so I have s squared, so I have enough s's there. So what we are going to do is we are going to multiply all 4 of these fractions by r squared, s squared. All right, this is where it's going to start to look a little sloppy. I'll try to zoom in to make this a little better. Okay, remember when we do this, we're multiplying the top by the r squared, s squared. I'm going to multiply this top by the r squared, s squared. This by the r squared, s squared, and this one by the r squared, s squared. We can only do this little trick we're doing if we multiply every single term within this large fraction by that denominator that we came up with. Okay, so here's what's going to happen. When we simplify this one, this r squared right here cancels with this r squared. And I'm left with s squared times 1, which is just s squared. Carry down my minus sign right here. Now this next one over here, I have an s squared, but I have an s squared up there, so that is going to cancel. My s squared cancels with my s squared, and we're left with 1 times r squared. Over. Now when I get to this part down here, this is only 1 r, but I have an r squared. So what happens is this r cancels away one of these r squared. So that turns into an r to the first power. Then I multiply that by 1 and I get rs squared. Minus, right here, this s is going to cancel away one of those s's. So this turns into s to the first power. And multiply that by 1 and you just get r squared s. Okay, so we just took a pretty complicated looking problem and now it just looks like this. So much better to work with, I think. When we try to simplify this fraction, we want to see if there's any factoring you can do, because then if you factor, you might be able to cancel some things out. We've got s squared minus r squared. That's going to be your difference of squares. It's going to factor into s plus r times s minus r. Now on the bottom, this looks a little bit weird, but I can see that there are some common factors. I've got an rs here, an rs here, so let's do some GCF factoring with this one. going to take an RS out, and it leaves me with an S minus R. Well, that was helpful because now we have an S minus R on the top and an S minus R on the bottom. And our final answer is S plus R over RS.